Now let's talk about the two's complement addition and its interpretations. As in one of the exam problems, okay, you are asked to add these two's complements numbers and determine the result and determine whether it is an overflow or not. All right, so let's just recall, and in two's complements, you treat the top left number as negative, okay, and negative 128 in this particular case, and negative top left. Therefore, in this case, you will actually means the number actually are negative 128 and negative 61. So the correct mathematics is negative 189. Now, if you do the binary addition, you will end up with this. So a carry 1 and this bit pattern. So that is your, if you just take 8 bits, because we're supposed to just take 8 bits as our answer. So we get 67. Obviously, if you just take the 67 as your math answer, it is wrong because the correct answer is supposed to be 189, negative. So we decided it's overflow. That's the correct answer. So using this way to encoding numbers with positive and negative, that in the computer programming language is called encoding the integer. So like in the case of C++, you will recall you have an integer type. That's how we actually use. But on a more generic standpoint, and we can encode whichever way we want. Okay, and two's complement encoding, it is one of many ways to encode integers. So now you can also encode integer with unsigned. So for example, the same question could be this bit pattern to be just 128, positive or no sign, and the other number is 195. So if you do the addition, the correct mathematics is 323. Now you do the same thing, you end up removing the top left bits and you end up with the 67. And then of course that's not correct math, they will say overflow. Okay, at current time we are learning two's complement encoding. That's the most general way of encoding numbers, integer numbers with positive and negative. So now how do you actually detect this overflow? That's the topic of this video. Okay, and the answer is if the math is incorrect. Okay, what do you mean by incorrect? You just choose the same number of bits. Okay, 8 bits, you take operand to be 8 bits, you take the result just 8 bits. Okay, so that if the result is incorrect, you say there's an overflow. Okay, but now, however, this way is also depend on what math you are doing. Okay, currently we're doing signed math, which means two's complements, and many cases on computer, and we encode the number unsigned. Actually, unsigned is actually easier, just the binary numbers without sign. So how do you determine whether it is overflow? Okay, let's just use the 4-bit example. Right? Instead of 8-bit, we use a simpler example, but the result will be also applicable to 8 bits. So we consider all these type of problems. So with 4 bits on top and 4 bit on the bottom. So with topmost left bit is called the sign bit of the either number, and the result also has 4 bits and with a negative sign bit. We call it n negative. And also we may have a carry may or may not have a carry bit as the result. So then how do you determine this addition is overflow or not overflow with the 2's complement encoding? Okay, I just figured out this formula. Okay, and with all this for S1, S2, and negative and C. So that's how you get the negative, get the whether overflow or not. Using our knowledge learned, this is the logic knowledge we learned from class. So for example, if these two numbers have different sign, which means one is positive, the other one is negative, or vice versa, you will have this one exclusive or be true. And then that next sign is negative. Then you have an and here. Then you have a false. Then, which means if the two numbers are different sign, you will never have a overflow. That's correct, right? So if a positive number plus a negative number, and you will never get an overflow because they all canceled. They will stay in the middle. So, and also some of you have this concept that, okay, whenever there's a carry, there may be an overflow. That's not necessarily true with this 2's complement interpretation. So if you have a carry over here, but if you don't have negative number, and then you will have may have an overflow because one is true, exclusive or is true. But if you have a carry in this result, but then the number is negative, the exclusive or is false, which means you don't have overflow. And so this logic expressions I figured out to cover all situations of this 4 bits addition, okay, in 2's complement. In fact, this is applicable to 8-bit, any bit, that's because only the top bit matters. Okay, only this 4 information matters. So let's check with the here what I mean by doing this. This is the 4-bit interpretations. Okay, so let's see. If you have this plus this, obviously you easily get this. So then how do we interpret this? With unsigned math, which means we say we are doing 3 plus 3. Is that correct? Then you get 6, correct. But now if we claim we are doing with the signed math, which means 2's complement math, we have 3 plus 3, and yes, it's correct. So that's all good. Either way you interpret this. Now there are some other situations. Now if we do this way, okay, 1 1 1 1 addition, another 1 1 1 1. Okay, now there are also 2 ways of interpretation of this. So if you say unsigned, that is what you're most familiar with, and it is 15 plus another 15, and the carry will come out. We drop it, which is the leftmost bits, and then you will end up with a 14. So you have incorrect. So you will say if unsigned, it is overflow. Now if we are doing signed, interestingly, so what is this? Think about it. That's -8. So you will have a -1 and -1 plus another -1. Then you have this. If you stick to the 2's complements interpretation, and this will be a -2. But if you see, even though that way is overflow, but if you interpret 2's complement, -1 and the -1, you have -2. It's perfectly okay. And in this case, you have a carry, but you also have a negative number, so still okay. So you have this is -2. So that's okay. So this one is yes. Now let's look at the other example, and this one. So 0, 1, 1, 1, another 0, 1, 1, 1. The addition is this. Just remind you that the computer, for math, only thing it can do is add. Okay? Then the matter is what is your interpretation of this addition? Okay? So then you get this. So now you have an unsigned interpretation. You will have 7 plus 7, you get 14. That's perfectly okay. So yes, it's right. But if we interpret it with our integers, which means 2's complement ones, you have 7 plus 7. And if you stick to our 2's complement interpretation, that is a -2. Incorrect. So therefore incorrect. So in this case, unsigned interpretation is correct, but the signed interpretation is correct. Okay, recall this situation. This unsigned interpretation is incorrect, but signed interpretation is correct. You can have all the situation vice versa. And of course, in this situation, okay, 0, 0, 0, 1, 0, 0, 1, another 1, 0, 0, 1, you will get a 1, 0. For the unsigned, you get 9 plus 9 equal 2, wrong. And it's wrong. And also you have signed, that's -7, another -7, but the result is a +2, also wrong. Okay, well, this one is right, and both wrong, and this one both correct. Okay, and but you can have this one right, the other one is wrong, or that one is wrong, and the other one is right. So you can amuse yourself to come up with all these situations. Okay, but how do you detect which one is for the unsigned, for the signed, of course, excuse me, for the signed, which is we are learning in a class. Actually, this is for the integer. It is all is summarized with this formula. Okay, so don't quote me. I believe this formula is somewhere in some books. But can you check this with your own examples? Please let me know if you find out wrong, especially. I think it's right. I checked with several examples. Is all correct? Okay. Hope this helps. Bye for now.